of functions. 3.5 is very important. We need to be able to look at a function and tell how it has moved, how it has changed, and to graph it more quickly than you would have in an Algebra 2 course. Because we want to get you ready for, hopefully, if you take calculus in your future. That's why it's called pre-calculus. So this skill is just a super important thing. So we're going to talk about shifting things left and right, up and down. We're going to talk about flipping them over the x-axis, flipping over the y-axis, how we can stretch and compress them, all these different things that a transformation will do. We learn those parent functions. Remember all those parent functions? The absolute value, the square root, the square, the quadratic, the cubic, all those things, because we wanted the basic that we can then transform into all these other functions. So let's take a look at how we can change a graph vertically. If and only if you add or subtract something on the outside of the function, so this plus k, will take and it will move it up or down. So if we add on the outside, then our function will move up. If we subtract on the outside, our function will move down. So that's important to know. So this right here, let's say that the one you see in blue is our parent function. That looks a lot like a cube root, or that would be a cube root. Let's assume it's that. And when I say on the outside of the function, so outside of the cube root, so we're talking about it looks as if they have moved that up 1. So that plus 1 would be on the outside of the function. Okay, so that is how we can move things up or down. So that works for any function. If that's a quadratic, so if it's x squared and we put a plus 1 on the outside, it's going to lift it up 1. If we put a minus 1 on the outside, it's going to push it down 1. So a vertical shift, moving something up or down, happens if we add or subtract something on the outside of the function. It is super important that you know by looking, if I put that plus 1 there, I can just take my original. Remember, we kind of learned those 3 points, those 3 good points. You could just take all of those 3 good points for a cube root or a square or any of them, and you can just lift them up 1, and you will get the correct graph. If we want to move something left or right, that is a horizontal shift, a left or right shift. If we add on the inside, it's going to move it to the left. If we subtract on the inside, it's going to move it to the right. So if we take that same cube root function, and we decide we want to move it to the left 1 unit, all you're going to do on the inside is add 1. So that would be the 2 functions that you see there on the right. So these major rules are what you want to know, that if we add on the inside, it moves left. Subtract on the inside moves right. Add on the outside moves up. Subtract on the outside moves down. Many times they will refer to the change in your horizontal shift as an H and your vertical shift as a K. So we can think of the fact that the center of the graph, the middle of the graph, the vertex of the graph has been moved to HK. And you need to know that the H is always the opposite of what you expect. The thing on the inside will always be the opposite of what you expect to happen. So these rules are super, super important. So let's look at how it appears with a table of a function. So we have this function listed in the first example here. Let's call this example 1. In example 1, we have this function f of x. And if we want to change the function, see here how we're changing it by subtracting on the outside. This should move the function down 3 units. So if it's at the on the outside of the function, it is only going to be affecting our y values. So if I plug in a 2, normally I would get 1, but g subtracts 3 from that. So 1 minus 3 is negative 2. Let's do the same thing for 4. 4 usually gives me a 3, but now I subtract 3, and it becomes a 0. 6 would have given me 7, but I have to subtract 3, and it becomes a 4. 8 normally would give me 11, but I have to subtract 3, and it becomes a 7. So you'll notice that it changed the y's. Did I subtract wrong? Oh, it sure would be. Thank you. Matt, you're always catching my weird mistakes. Okay, so now let's take a look at the difference in example 1 from example 2. From example 2, the subtraction is on the inside. It is going to change our x's. But what's weird about it is it does the opposite of what you expect, okay? Because x minus 3 equals 2 now at 5. See how it adds 3 onto it. So for our new function, all of our x's change by the opposite of what we see. We have to add 3. And so this would be 5. This would be 7 because x minus 3 equals 4 at 7 now. The next one would be 9. And the last one would be 11. So what this did is if you had to describe what happened, our graph went to the right 3 units. So on the inside, we change our x's, and you always end up doing the opposite of what you see. And that's just the nature of the fact that it's on the inside of the function. And I always think, where does that inside equal 0? And that's a good way to tell me how it changes. That's a good way to tell me how it changes. So if it's on the outside, it does what you see. If it's on the inside, it does the opposite of what you see. Inside stuff affects the x's, the input. Outside stuff affects my final result, my output. So there is example 1 and 2. And if we were to plot these points on a graph, this original set of points would go down 3 units, if we saw that. This set of points would go to the right 3 units. So the Y's are a little nicer. They kind of do what you expect. The X's are a little funky. They do the opposite of what you would expect. It does the opposite of what's in there. And it's kind of about order of operations. It's about a mixture of things as to why that happens. Okay. So let's look at this example and let's graph it quicker than we normally would have, okay? Hopefully. So let me put my X and Y axis on here. And I am going to put my parent function. So if we look, our parent function is y equals x squared. And let's put that on there. So then we can easily pick up our points. Now you really only need about 3 points. I'm going to put 5 just so I get a nicer picture, because I'm not the greatest grapher as far as making it real nice and neat. So the more points I have, it helps me get my graph a little nicer. So what's going to happen is that addition on the inside, is going to move everything to the left 1 unit. Now, if you're unsure about what's happening, all you got to do is set x plus 1 equal to 0 to see where the vertex or the center has gone. It has now gone to -1. This thing on the or the outside here is going to move it down 2. So to subtract 2 on the outside moves it down 2 units. So all we're going to do is we're going to go into our graph, and we're going to take all of those nice points that we know the parent function hits, and we are going to move them to the left 1 and down 2. So let's do that. So just take each point, left 1, down 2. So this point here, the vertex is now at the point -1, -2. And you can just move all of them. Left 1, down 2. Left 1, down 2. Left 1, down 2. Left 1, down 2. And look at how easily we got our graph. So that's really, really nice to do. Now, we could always plug in some points. I mean, there's so many ways to graph a line. So feel free to do, or to graph a quadratic or any kind of our parent functions. But our job in section 3.5 is to be able to graph things a little quicker than we normally do. And that's our goal, okay? Any questions about how to graph that parabola? So our original was the blue one. That's our parent function. We're just going to take and pick those points up. We're going to go 1 to the left and 2 down for every single point, and that kind of creates that parent function. So you need to know, if I subtract on the inside, I'm going to move right. If I add on the inside, I'm going to move left. If I subtract on the outside, go down. If you add on the outside, go up. And so that's really important you know those 4 rules. Let's do another one. So we see our parent function in the graph, and it says translate it to make the graph of y equals x plus 3 squared plus 2. So let me kind of write this to the side here so we can kind of pull it apart. Adding on the inside of our function is going to move that to the left. Adding on the outside of the function, it's going to move that up. If you're unsure, the one on the inside is the one that gives people most difficulty. You can just set x plus 3 equal to 0 and solve for where that vertex goes. See how my vertex goes to an x value of -3. It jumped to the left 3. So now let's take those good points on our parent function and let's scooch them over to the left 3 and up 2. So just count to the left 3 and up 2. I usually do my vertex first. My vertex is now at -3, 2. And then I do all my other points. And then I get my parabola. Now I'm not sure how Alex, how many points Alex wants you to do. I would say at least 3, if not 5. But if you know those parent function points 0, 0, -1, 1, +1, 1, -2, 4, +2, 4, then you just have to shift them 3 to the left and 2 up. And so that, you know, in an Algebra 2 course, your teacher might have you plug in points. They might have you do just a mixture of things. Our goal is to get our graphing done a little quicker. So you saw how quick that was to graph that. Does anybody have any questions about that problem? Okay. So let's take a look at this one. It says the graph of our parabola is shown. Translate it to get the graph of y equals the quantity of x plus 5 squared and y equals x squared minus 3. So this one is a inside we have added. And so what have we learned that if we add on the inside it does? What happens when we add on the inside? It moves to the left. So we're going to go left 5. So we're just going to take those parent function good points and just pick them all up, scooch them over to the left 5, and we've got it. And so the first one here goes here, and then just take them and scooch them over. So all I did was take each point, went over 5, just scooch them over to the left 5, and draw your new parent or your new baby function. Now the b, that -3 is on the outside of the square. It's on the outside of the function. So what happens if you subtract on the outside of the function? Moves it down 3. So this one's going to go down 3. So let's just take our good old points and just scooch each one of those down 3 units. So just count from each point down 3. You can see down 3, down 3, down 3, down 3, down 3. Everything will just drop down 3 and make your new parabola. Okay. So a lot of the things you'll be doing in Alex are just practicing moving those things around. Everybody okay with that one? Okay, let's do 2 more. So here, if we add on the outside, what's going to happen to this one? When we add on the outside, it does what you think. Adding, you would think, would go up. And so outside one, remember, always does what you think it's going to do. So it's going to go up. So let's take this graph over here. Let's kind of dot out those nice points. Let's pick them all up and scooch them all up 3. So if we pick this one that goes here and here and here, and it looks something like that. What did we say happens when we add on the inside of the function? It moves left. That one takes us to the opposite, but you can always set x plus 1 equal to 0, and that will tell you where the new vertex is going to sit. It's going to go to the left one. So on the outside, it does what you want it to do. Takes the y's and moves them up if you're positive, down if you're negative. The inside does the opposite of what you want. So take all these points and let's scooch them just over 1. So I always dot out my nice points and pick them up and move them over 1. Now, I don't know if Alex lets you just actually physically just pick that parabola up and it will move the whole thing, or if you have to point by point. I don't know. So you'll have to let me know how that works. Yes. Does it let you drag it to the left one? That's great. I hope it does. Okay, any questions about those ones? Okay, so we are going to skip this example. We're going to come back to it once we talk more about what happens if we have a multiple on the outside of the function. So skip this one for now. We'll come back to it. Let's see what we want. And then if we could jump down, we'll come back to all of those examples. If you could jump to your 3-5A homework. I don't have any multiples on there. I'll come back to those facts when we go over some notes tomorrow. Each one of these functions, it's going to take the parent function. It's either going to move it left, right, up, or down. No multiples of anything yet. So that's where we want to stop. And you can work on this homework. So far, due on Monday is going to be 3-6, 3-7, and 3-5A. I'll let you know if we get how far we get tomorrow as to if 3-5B. I would assume we're going to get to it, but so far we have 3-6, 3-7, and 3-5A that you can be working on. So take the rest of class or work on those things, and I can help you with whatever you need help with.